Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic of the lecture is Dalton's atomic theory. First of all, Dalton atomic theory was given by the scientist named as Dalton. It's Dalton in 1808. So, what were the postulates of this theory? So, I'm writing it in a very sequential manner. The very first postulate states that matter is made up of extremely extremely small indivisible particles, and we call that indivisible particles that's called atoms. So let us talk something about atoms. There are about 118 types of atoms, and a specific matter will contain specifically one or two types of atoms. So these 118 types of atoms is known as elements. So in short, we are having 118 elements because every element is unique in itself. That means one element cannot match the another element in respect of size, shape, the number of electrons, the protons, the neutrons that we will discuss in the further topics. So let's talk about the second postulate. Atoms of same element are identical in all respects, that is size, shape and mass. Atoms of same element is identical in all respects, that is size, shape and mass. Let me take an example. If I'm talking about one atom of nitrogen and I'm also talking about another atom which is also of nitrogen, I'm having another atom of nitrogen example. I'm symbolizing nitrogen like N as also N. These two N are identical in all respects, that is size, shape, mass, the number of electrons, protons, neutrons. So let us move at the third postulate. Atoms of different element will have different masses. Atoms of different elements will have different masses, size, shape, even the number of electrons, protons, etc. I'm not writing the number of electron protons right now because at that time when the Dalton given this theory, the no one knows about the electrons, protons and the neutrons, but right now due to the advanced technical uh, advances in the chemistry, we are able to find out the number of electrons, protons, and every atom, sorry, every type of element have the different number of electron, protons, and neutrons, which we will discuss in the next topics. So the third point states that the atom of different elements will have different masses, size, shape, etc. That means if I'm having nitrogen atom and if I'm having the oxygen atom, the both atoms will have different mass, different size, and a different shape. So let me move to the fourth point. Now fourth point says that at atoms of same or different elements, atoms of same or different elements combine together to form molecules. To form molecules. Now, obviously, when N combines with N, it forms N2, and when N combines with O, it forms nitrogen monoxide. When N combines with 3H, it forms NH3. So, this was the fourth point given by Dalton. So, let us talk about the fifth point. When atoms combine with one another, when atom combines with one another, to form molecules, they always combine in simple whole number ratio. They always combine in simple whole number ratios. By masses or by their numbers also, or by their per molecule. Let me write an example. I'm writing NH3. Here the number of nitrogen atoms are 1, the number of hydrogen atoms are 3, so it comes out to 1 is to 3, which is always fixed for nitrogen. And if we will calculate its weight, then that will also be the simple whole number. That the weight of nitrogen is 14 and that of hydrogen is 1, and they are 3 in number, so it's 3. So that's the first one was ratio by number, and another one was the ratio by mass. Let me take another example for you. I am talking about the carbon dioxide. The ratio by number of atom per molecule. Ratio by number of atom per molecule. The carbon are 1 in number and oxygen are 2 in number, so it's 1 is to 2. And ratio by mass. The weight of carbon is 12 and that of oxygen is 16. Now 16 into 2 comes out to be 32. It's 12 is to 32. The simplest ratio comes out to be 3 is to 8. So let's move to the another point. That's the sixth point. Atoms of two elements may combine in different ratios to form more than one compound. Let me write this thing for you. Atoms of different elements combines in different ratios to form two or more compounds. I have given you the example of nitrogen and oxygen when I was taking the lecture of law of multiple proportion. Nitrogen and oxygen to form combines to form two or more compounds. There were five in number actually. The first one was N2O, the second was NO, the third was N2O3, the fourth was N2O4, and fifth was N2O5. Different ratios. The first one was 2:1. We were having two atoms of nitrogen and one of oxygen. So the first one was the ratio of atoms by number in N2O is 2:1, in NO is 1:1, in N2O3 is two atoms of nitrogen combines with three atoms of oxygen is 2:3. In N2O4 it's 2:4, which can be further simplified to 1:2. In N2O5 the ratio was 2:5, which is the simplest whole number ratio. So 6 point states that the atom of different elements, that is nitrogen and oxygen, combines in different ratios to form two or more compounds. I have shown you the different ratios in which they are combining to form different compounds. That's N2O, NO, N2O3, N2O4, ND, N2O5. Now let me move to the point number 7. An atom is the smallest particle that take part in a chemical reaction. Whenever a chemical reaction goes on, the atom is the smallest particle of a matter that take parts in chemical bondings in a specified chemical change. I'm not talking about the physical, a chemical reaction. An atom is the smallest particle that take parts in a chemical reaction. That take parts in a chemical reactions. When I will move to the further topics, I will give you the tips about the chemical reaction and how to calculate their products. So I'm here to make you understand chemistry. I will not give you tips to learn the chemistry. I will give you tips to understand and solve the chemistry. Now I'm coming to the point number 8, postulate number 8. An atom can neither be created nor destroyed. So the eighth point, an atom can neither be created nor destroyed. This eighth point supports the law of conservation of mass. So that was the whole Dalton Atomic theory. So my dear students, we have done the 4 laws. The students who haven't seen the previous lecture, please go and check it out. The law of conservation of mass, the law of definite proportions, the law of multiple proportion, and the law of reciprocal proportion. So now I'm going to mention the postulates of Dalton atomic theory which supports these laws. So firstly, I have done with you the law of conservation of mass. The law of conservation of mass is supported by the 8th postulate. Law of conservation of mass. What does that law states? Law of conservation of mass states that mass can neither be created nor it can be destroyed, because in a chemical change always atom takes part in the reaction, so atom can neither be created nor destroyed, although it can be it can be moved from one compound to the another compound. So atoms doesn't get created nor destroyed in a chemical reaction, so their mass is always conserved. In this law I have told you that the total mass of reactants was equal to the total mass of products. So the law of conservation of mass is supported by the eighth postulate of Dalton atomic theory, that atom can neither be created nor destroyed, so their masses is also conserved. The masses of atoms is also conserved, and hence this law raised, that's the law of conservation of mass. So my dear student, the first law, hopefully you understood the first law, that's the law of conservation of mass, that has been supported by the eighth postulate of Dalton. So let me talk about the law of constant composition. The law of constant composition is supported by the fifth postulate. When an atom combines with one another to form molecules, they always combine in simple whole number ratio by their masses or by their number of atoms per molecule. Number of atoms, here it is, per molecule. So the law of definite proportions. The law of definite proportions is supported by the fifth postulate. What does law of definite proportion states? The law of definite proportion states that a pure compound, can it be like CO2? I have also taken the example of CO2 in that video also. It says that the pure compound, that is CO2, bears a whole number ratio by their masses, irrespective of the source of origin of the carbon dioxide or that compound. So again, what does the fifth postulate is stating? It says that when atom combines with one another to form molecules, they always combine in the simple ratios by their masses or by their number of molecules, by their numbers per molecule. That is CO2, the number of carbon is 1 and that of oxygen is 2, so the ratio was 1:2. Number of, or more specifically, the number of atoms per molecules. Number of atoms per molecule. So law of definite proportion is supported by the fifth postulate. Now comes the law of multiple proportions. That's the sixth point. What does law of multiple proportion states? The law of multiple proportion states that when two or more element combines to form two or more compounds, then the ratio of masses of one atom or one element combining with the fixed weight of another atom or element, that ratio is simple whole number. So again, what does the sixth point say? Stating that the atoms of different elements combine in different ratios to form two or more compounds. This postulate supports the law of multiple proportions. So next, the law of reciprocal proportion. Now the law of reciprocal proportion is all again supported by the fifth point. Let me take some another color. colors matching the white one. The law of reciprocal proportion is supported by again the fifth postulate. Law of reciprocal proportions. The law of reciprocal proportion states that the ratio of masses of two elements combined with the fixed weight of third element is either the same or whole number multiple of ratio of masses when that two elements directly combine with each other. I know that this definition was a little bit confusing. To understand this, please go back to the my lecture, that's the law of reciprocal proportion with numericals. So here, if the ratios was fixed, which I have taken 3 is to 8, which I have calculated to be 3 is to 8 for carbon dioxide, if this ratio was constant, that's why I was able to evaluate the law of reciprocal proportion. If any student haven't got this point, please go back to my lecture, the law of reciprocal proportion, to understand that thing. So hopefully, my dear students, you all understood the Dalton atomic theory. But in Dalton atomic theory, there were certain limitations. So let us talk about the limitations of Dalton atomic theory. Now, the very first limitation. The first limitation of Dalton atomic theory. The first limitation was that this theory explained all the laws of chemical combinations. Let me recapitulate the all laws which the Dalton atomic theory has explained. The first law was the law of conservation of mass. The second law was law of definite proportions. The third was law of multiple proportions. And the fourth law was law of reciprocal proportions. My dear students, here one law is missing. So can anybody make the guess which law is missing? So please go back to my channel. All the topics are in a sequential manner. The fifth law. What was that? Which fifth law? The fifth law was Gay-Lussac's law of gaseous volumes. The Gay-Lussac's law of gaseous volume. Dalton atomic theory was failed to explain this law. Dalton atomic theory failed to explain this law. So this was the first drawback or the limitation of Dalton atomic theory, that it could explain the laws of chemical combination, but it failed to explain the Gay-Lussac's law of gaseous volume. So let us move to the second point. It could not explain the reason. This theory, it could not explain the reason explain the reason why different types of atoms, why different types of atoms or elements have different size, shape, and mass. But due to the advances of chemistry, we all know today that the element differ with respect to the number of electrons, protons, and neutrons. At the time of Dalton, the electron protons was not discovered. So that's why this theory could not explain why different atoms or the different types of elements or different types of atoms have different size, shape, and masses. Dalton atomic theory said yes, they are different, but why they are different? This reason was not given by Dalton. That's why this theory has a limitation. Now let's move to the third point. The Dalton atomic theory told yes that atom combines with each other in a specific ratio to form the compounds. But why they are combining? What's the reason why the atoms are combining with each other? Again, Dalton atomic theory was unable to give the reason. Again, it could not explain. It could not explain why atoms of different element, why atoms of different elements combines in specific ratio by their masses or number, in specific ratios by their masses or specific ratio of number of atoms. Let me write it complete, sorry. Ratios of number of atoms per molecule. So this was the limitation, that it could not explain the reason that why atoms of different elements combines in specific ratio by their masses or specific ratios of number of atoms per molecule. So the reason behind their combination was not given by Dalton. Now the fourth point. And the fourth point was that Dalton said that atoms combine with each other, but Daltons haven't discussed about the nature of binding forces between the atoms or molecules, which accounts for their existence. So it could not explain the Dalton atomic theory. It could not explain the nature of binding forces, nature of binding forces between atoms in different compounds or molecules. But again, due to the advances of chemistry, we now today know that the binding forces are like covalent bonds, the ionic bonds, coordinate bonds, the London dispersion forces, the ion dipole interaction, the dipole interaction. We are having the lot of nature of binding forces. We are having a lot of type of forces. But at that time, in 1808, it's a very back time. In 1808, the chemistry equipments was not that much advanced, so he Dalton gave us the rough idea, but he could not explain the reasons. But his idea was correct, but the reason about the existence of that type of compounds was not given by Dalton. So it could not explain the nature of binding forces between the atoms in different compounds or the molecules. The fifth limitation, it makes no distinction between the it makes no distinction between the ultimate particle of atom no sorry ultimate particle of element and compound. The ultimate particle of element is obviously atom, we all know that, but in case of compound the ultimate particle is a single molecule. For example, if I'm talking about the chlorine gas, in chlorine gas, what is chlorine gas? It's a compound. The ultimate particle of chlorine gas will be Cl2 molecule, and the ultimate particle of chlorine will be the single atom. If I'm speaking the word only chlorine, then I'm talking about the chlorine atom. If I'm saying it's chlorine gas, then it's Cl2 gas, and the ultimate particle of chlorine gas is Cl2, and that of chlorine is chlorine atom. So this thing we know in the today's world, but in 1808 this thing was not known. So it is also the drawback or limitation of Dalton atomic theory. So that's all for today's lecture. So I have given you the limitations of Dalton atomic theory, and I have discussed with you the whole Dalton atomic theory. I hope you all understood today's lecture. I have given my phone number on the thumbnail of this lecture. So if any one of you wants to book a paid one-to-one online class to clear doubts, contact me on my phone number. Please like, subscribe and share my channel to maximum number of students. Don't forget to press subscribe button of my channel. Stay blessed.